Oh, welcome to the live stream today. So, today we're diving into a big patent moment for Anthropic, which is the company behind Claude, one of the big AI chatbots. And they just got their very first US patent granted. Believe it or not, it's for me, it's always a bit surprising that, AI chatbots is probably one of the biggest or fastest growing industries on our planet, but patent-wise, the real innovators like OpenAI and also Anthropic have very small patent portfolios so far. So it was interesting for me to see that Anthropic got their very first US patent granted only a few weeks ago, and we will look into that one in today's live stream. So this patent is not a small one; it's over 200 pages long, and it focuses on multimodal AI agents. So those are computer programs, AIs that can not only produce text, but they can actually use computers the way we humans do. That is kind of Anthropic's mission here. So, on the surface, the patent is an interesting technical read, but it also comes with a fascinating backstory that connects, big players like Google Brain, Adept, Anthropic, and even Amazon. We will look into that in a second. So, in this session today, we're going to unpack what's inside the patent, of course, and we will also talk about how it kind of fits, into the bigger chess game over maybe who will control the future of agentic AI. Before we dive in, a couple quick things. Number one, please hit the like button. It really helps more people discover these videos here. And secondly, if you are watching this live on LinkedIn, please don't be shy. Put your questions in the chat as always, and I'll try to pick up some of the questions as we go. Okay. So let's dive right in. The backstory story first, it goes something like from transformers to agents. So, first of all, let's rewind to where this all really started. And it was back in 2017, a long time ago for the AI age. So, there was a small team at a company called Google Brain, which came up with something called the transformer architecture. So the transformer is basically a clever way for a machine, let's say, to pay attention to the most important parts of a sentence instead of just having to rely on it, word by word in order. So this was really a breakthrough made at the time, and today's large language models almost all rely on the transformer architecture. The GPTs, Claude, Google Gemini, you name it, all are transformer models, and they run on this basic idea. So this idea was first outlined, as I said, in 2017 in the famous paper, Attention is All You Need. Let's have a quick look at that one. Here, maybe you've seen it, Attention is All You Need. Here you have the whole Google crew, so to say, and here in this paper they came up with the famous transformer model architecture. So two key people behind, there's a lot of authors in here, all from Google, but two key people here behind this paper are Ashish Vaswani, I hope I don't butcher his name, and also Nikki Parmar. And we will hear more about them in a second. This was in 2017, right? Fast forward 5 years. Now it's 2022. Vaswani and Parma, they and also some other people leave Google to build their next venture, which was a company called Adept. And we can see this, for example, in their LinkedIn profiles. So this is Ashish Vaswani, and we can see in his profile here he was a computer scientist like myself, but he was more of a researcher, obviously, than I am. He was here at Google Brain, where they wrote the Attention is All You Need paper and came up with the transformer architecture. And then in 2022, he co-founded Adept. And same goes for Nikki Parma, the co-author of the transformer paper. Also, she was here at Google Brain for years and then co-founded Adept, right? Now, at Adept, this new company, their mission was not just more chatbots and more language generation, but AI agents that can actually do things, right? So, what they created was the so called Adept Workflow Language, AWL. So, what is AWL? Well, it's, let's look at the website briefly. It's an expressive custom language that allows users to easily compose powerful multimodal web interactions on top of Adapt's models. So, Adapt was also building their own AI models, and they also developed this language, this Adapt workflow language, where you could basically, kind of program your AI agents. So I think one unique thing about this language is that it kind of combines, on the one hand, natural language, with so you can have human instructions, and on the other hand, precise commands that precisely map to computer actions. So it's kind of bridging the gap between human understandability and preciseness in order to control the actions that the agent is supposed to perform. Now, what makes AWL so powerful is its multimodal nature. And we will hear that a lot also when we look at the patent. Multimodal means that you can have more than text, you can have images, videos, voice, whatever, different kind of input modalities. That's why it's multimodal. Okay, so that was Adapt, right? They developed this agent programming language in the broadest sense. Then, next step, 2 years later, in 2024, actually Amazon steps in. So they hire some of Adapt's co-founders. So Adapt, I think, is still existing today, but most of the co-founders were hired by Amazon. But not all, because finally this year in 2025, Nikki Palmer, remember, the one co-founder, the one co-author of the foundational transformer architecture, she did not go to Amazon, but she joins Anthropic. Here, she's now a member of technical staff at Anthropic since January, and that's where kind of the circle closes to today's patent, because this is the Anthropic's first US patent, and it's all about agentic AI and about Adapt's workflow language technology, right? So that's for the backstory, so to say. Now let's have a look into the patent, shall we? Because we are here all patent nerds, hopefully, hopefully you are a patent nerd as I am. So let's have a look here at this wonderful patent today. So the title is Multimodal Agent for Efficient Image Text Interface Automation. So you can see we have this multimodal aspect again here. The patentee is Anthropic, of course, as I said. First, let's look at the timing, maybe. So this is a real rocket docket. The patent was filed in October 2024, right? And it was granted in, roughly 4 or 5 weeks ago in August 2025. So less than a year from filing to grant, even before publication, right? So that's funny about these kinds of AI patents. OpenAI also does the same strategy. If you file a patent application at the USPTO, you can pay an extra fee, and then you can get into the so-called Track 1 program, which is some kind of prioritized examination track. Typically, you get the first office action within 1 to 2 months, in my experience, and most of the time, if your patent gets granted, you get it granted within under 1 year. So there will be no previous publication of the patent application, but from the outside, you see nothing, and then suddenly the patent pops up. That's an interesting strategy, which seems to be popular in the AI scene here, because OpenAI is a heavy user of the Track 1 requests, and also here, Anthropic has done it with their first patent. So, Rocket Docket. I think it's, if I see it correctly, 10 months from filing to grant. ownership, as I said, the patentee is Anthropic, but the patent actually claims the priority of a whole series of provisional applications. That's what you do in the US oftentimes. So the earliest priorities here are from the earliest provisionals were filed in March 2024. I think like 3 of them on the same day. And then we have another bunch in April 2024. So first priority filings in March, then some more in April, and then in October we have the non-provisional filed. So a rather quick series of provisionals, and then the non-provisional was within 7 months in total. So what does that tell us? Maybe, I don't know, maybe they were afraid that someone else would come out ahead of them, right? So I don't know, probably they thought that they were up to something here, and they needed to move fast, and they locked in these intermediary provisionals before they had the non-provisional filing ready. Okay, so what's inside the patent now? As I said, it's a real monster. It has exactly 234 pages, and it has a total of 174 figures, which is kind of crazy in my opinion. So yeah, it's rarely that I see a patent that is so extensive, right? Let's have a quick look. So the patent actually the figures start with, some basics overview over the transformer architecture here. So if you've ever read the Attention is All You Need paper, you will, remember these kinds of, I think this is pretty much the same structure, the same model as in the transformer architecture. So that's more or less common sense, I would say, or gives some kind of technical context, and also shows that the authors have the transformer architecture in their minds because they were inventing it a couple of years ago. The specification then goes on, and this is interesting, I would say, with kind of a stylistic break here. We had nice patent drawings, and now we are suddenly seeing figures which are in reality some kind of presentation slides. So it seems to me, so we have here lots of slides, then we have some formalized user interface drawings, some picked screenshots, then we have slides again, then we have all sorts of stuff here. I'm just here patent figures again, some strange figures in Comic Sans font or whatever. So this is kind of a mess. I don't know. So the figures, I don't know. I think it shows that this patent has been probably assembled either in a hurry or just from multiple sources with limited budget. I don't know. So it's really kind of put together from different sources. So let's try to find actually the end of the figures. I said it's 174 figures, so we should be right at the end. Yeah, and here the actual specification starts. So also the specification is kind of put together. That's kind of interesting because it starts out, pretty conventionally, field of the technology, background section, and then in the background section it starts out with this typical patent lingo storytelling, but then in column 3 it starts here, for example, like it says, let me try to no, it doesn't work. So it starts with some kind of marketing brochure like or pitch deck like presentation about the company Adept actually. So it says Adept is an machine learning research and product lab building general intelligence by enabling people and computers to work together creatively. We believe that AI systems should be built with users at the center, and so on. Talks about the co-founders Vaswani and Parma, who invented the transformer. That's why we are starting Adept. We are training a neural network to use every software tool and API in the world. a universal collaborator for every knowledge worker. So this is obviously copied from some, I don't know, pitch deck or something, right? It also talks about the Adept workflow language here. So again, here we are closing the circle. Then in the summary section of the specification, we have a total of, I think, 10 independent embodiments. So this is really not a very not a normal patent in the sense that it's about one invention, but it's kind of a a reservoir, a kind of platform patent with a whole bunch of inventions in there. So first of all, we have a system for generating training data to train agents. Then we have a system for interface automation. So what else do we have? A system for constructing prompts that cause an agent to automate multimodal interface workflows. We have another system for interface automation. We have a system for constructing prompts again, a system for client-side implementation of an interface automation language at runtime, a system for automating software usage. What else? A system for providing artificial intelligence agents. Okay. A system for image text agentic interface automation. And lastly, a system for magnitude invariant image text agentic interface automation. So a total of 10, if I counted correctly, independent embodiments combined into one patent filing here. So then the description goes on with the figure description, the detailed description of embodiments. Also here we have the different topics, like the overall system architecture, the training, the Adept language, and so on. And then at the end of the detailed description, we have at the end clauses, which are actually for each of those distinct inventions actually claim like sentences which kind of can be activated later, probably in divisional patents, right? And these are quite extensive. So we have like claim sets. For example, this first clause set here is about the Adept recorder. It has like let me see, 36 clauses, and there's even more extensive parts. So this one here has actually like 104 clauses. Then there is one for the Adept workflow language, again with 40 clauses. So a lot of material in here, nicely structured into claim-like sets. So this patent, I guess we will see it around for quite some time, because if I were Anthropic, I would branch off multiple patents from that, because it has so much material in it. Now, what is actually claimed in this one? What is actually protected in this patent? Let's look at the actual claims at the very end of the document. So we have an independent system claim, and then we have another system claim and a method claim. Let's maybe focus on the method claim for the sake of understandability here, because it's a bit more concise. So let's see if I can bring this up to the screen here. Yeah, okay. So we have a computer implemented method for image text agentic interface automation. So as I was telling you in the beginning, the whole backstory and the whole development of first Adept and then the transition to Anthropic was about multimodal agents, so agents that can not only process text but all different kinds of modalities. So here we talk about image text agentic interface automation. What is this all about? Maybe we do not really have to go through the claim line by line here, but what this claim is essentially about is the idea of storing an input text and an input image, and you want to process the text and the image with the same AI architecture, with the same decoder-only transformer logic here, without any embedding lookup. And what you do in order so that you can also not only feed text a one-dimensional sequence of tokens into this transformer, what it is designed for, but in order so that you can also feed an image into this transformer. What you do is you're taking the two-dimensional image and you are kind of serializing it in that this claim it says here it extracts image patches from the input image on a line by line basis, and it interleaves a new line character between successive lines of image patches. So what it basically does, it turns this two-dimensional picture into a one-dimensional, sequence of lines, image lines, so to say. You can feed those nicely into the transformer because the transformer is made for, sequential inputs. But if you would do that, you would lose, the context information about, how do the image patches relate to each other in the different lines. So what you do is you put after each image line, you put a new line character, and then the next line, new line character, next line. And so the transformer can know, okay, this is the first line, this is the second line, this is the third line of the image, and it can, see how the patches relate to each other in the two-dimensional space, even though the input was made sequentially, right? So I guess that's the gist of this claim here, and therefore this patent in this case, although it discloses all sorts of other maybe much broader inventions, right? For me, that's an interesting choice because on the one hand, obviously this patent claim was granted, right? So it was successful. They got their first US patent. On the other hand, this is, I would say, out of the 10 inventions disclosed in the overall document, this is probably the most nitty-gritty technical one, right? Maybe they deliberately started with that one in order to get a quick patent granted, right? Because it's always easier to get, nitty-gritty technical stuff patented than, the broader concepts. Maybe that was the intention here. On the other hand, in terms of, let's say, detectability, which is one of the driving factors of the value of a patent, right? Um, I think this is kind of difficult, maybe, because it basically all happens under the hood, right? So all you see from the outside is maybe that you can put in text and an image, but from the outside you don't see if another AI chatbot, really, really divides the image up into patches, into lines, and then inserts new line characters. Those things you probably wouldn't see from the outside. So in terms of detectability, so and so, but nevertheless, well, it's the first patent, so first success, and I'm pretty sure that we will see this patent again in different shapes with different claim sets taken from one of the other sets of clauses which we looked at, right? Okay, so what does this say about the bigger picture in the, let's say, agentic AI space? I would say the story is certainly from conversation to orchestration, right? So this pattern shows that Anthropic is really not just about having Claude as a typical, text chatbot. You put text prompts in and you get text responses back. It really shows that Anthropic is probably more on the road to, orchestration, managing tools, APIs, connecting things, making their models, actionable so that they can really do things. And their goal is to have an AI agent that can actually control any kind of computer like we humans would do. Why do patents matter in this space? Well, a 200-page first issued patent signals certainly that Anthropic here has an intent to really stake an early claim into agentic AI, right? And I guess in fast-moving fields like AI, these kind of platform patents with lots of potential for further partial patents, so to say, can become very powerful bargaining chips in licensing, in partnerships, in litigation. Who knows what will happen next, right? So what's the takeaway? Well, Anthropic's first US patent is certainly more than just technical. It's kind of a strategic marker, right? They are building an AI that doesn't just generate words, but that it can actually act in the digital world, and they are kind of cementing, claiming their stake with this big comprehensive patent here. Although the first granted version here is limited to a very specific technical part in the overall picture, this thing has potential to spawn off multiple other patents, and we will hopefully see in the near future what happens next here. I will certainly watch this patent family, and we'll probably make another live chat when another one comes up. There is one question in the chat. Thank you for this live. Yeah, you're welcome. Have you any clue about a sister application before the EPO? Right now, there is none visible from the outside because, as I said, this is this kind of rocket docket strategy. Anthropic has filed certain US provisionals, and then 7 months later, the US non-provisional filed a track 1 request for accelerated processing and got the patent granted within 10 months. So even before the application was published, and even, let's see, I think even before the priority date is over. So let me go to the first page. So no, that's not true. That's not true. So the earliest priority date is March 2024. So they should have filed a PCT application already, but then again, March 25. If I see this correctly, we do not know yet whether they filed a PCT application or, for example, European patent application, because 18 months after this priority date would be September 2025. So actually, probably these patent applications would be published in the next few days or maybe next week. So probably I will write an update on LinkedIn when I see a patent family member. I'm pretty sure that they will file a PCT application, right? Who wouldn't, with such a comprehensive disclosure? But right now, the patent registers do not show anything. We don't know yet. I will let you know. We'll know in a few days. Exactly. Yeah. That's what it is. Exactly. Okay, so this was today's deep dive into another, for me at least, very exciting and interesting AI patent. If you enjoyed this deep dive, and if you are enjoying these kinds of deep dives in general, please hit the like button, follow me here on LinkedIn, and also please share this video with a colleague who might be interested. Okay, so thanks for watching, and see you in the next one.